Scenario 1. Jacob is a businessman who has to travel 10 kilometers to reach his office in city A. At the crack of dawn, he starts to his office in his car to avoid the traffic. He travels at a constant speed of 20 kilometers per hour and reaches his office in 30 minutes. But at night, when he leaves his office, he travels at a constant speed of 40 kilometers per hour and covers the 10 kilometers within 15 minutes. Scenario 2. Alexa, a food blogger, is known for her craze for pizza. On this particular day, she took 1 hour to eat the whole pizza. Next day, to her surprise, her friend Isha visited her. Alexa had no other choice but to share the pizza with Isha, and both of them completed the full pizza in half an hour. So, what do you think about the two scenes that just occurred? You haven't guessed yet? Don't worry, it is called the inverse proportion. What is an inverse proportion? It is something that occurs when two objects are inversely proportional to each other. That is, if an increase in the value of one variable leads to a decrease in the value of the other, similarly, decrease in the value of one variable leads to an increase in the value of the other. In mathematical notations, if A and B are two variables, if A is inversely proportional to B, then the product will always be equal to a constant K. For example, let's take a look at this scenario which we saw at the beginning. From this scenario, we know that Jacob reaches 15 minutes earlier to his house at a speed of 40 km per hour. Now clearly, as the speed increased, the time it took to cover the whole distance decreased. Therefore, both these variables, that is the speed and the time taken to cover 10 km in a day, are inversely proportional to each other when the distance is constant. Just like the first one, in the second scenario too, both friends Alexa and Isha completed the pizza in 30 minutes. As the pizza was shared by two, it only took half the time to complete it. If more people work on a task, then it will take less time to complete the task when the work is constant. Therefore, the number of people and the time taken to complete the work are inversely proportional to each other when the work is constant. Fine, now that we have learnt about inverse proportion, let's solve a question. Here the question reads, a man walked from his house to office at 5 miles per hour and got 20 minutes late. If he had travelled at 7.5 miles per hour, then he would have reached 12 minutes early. What is the distance between his office and the house? Doesn't this seem similar to the first scenario we just saw? Okay, let's take a look at how to solve this in a first conventional method that we call as equation method. Here, let's take d as the distance and t as the exact time that is supposed to be spent on travelling a distance from house to office. Let's come up with the formula on the basis of time taken. We know that time is nothing but distance travelled by speed, and that will be d by 5 for the first scenario, and in the question it's given that when he travels at a speed of 5 miles per hour, he is late by 20 minutes. So we can write the time taken as t plus 20 by 60. As he is late by 20 minutes, he will take more time, isn't it? Hence, we have used plus 20 here, and to convert minutes to hours, we have divided 20 by 60. We know that 1 hour is 60 minutes. Now the first equation would look like this. D by 5 is equivalent to t plus 20 by 60. Let's solve the second equation now using the second scenario. It's been given that when he travels at a speed of 7.5 miles per hour, he is early by 12 minutes. We're following the same process of the first equation. The second equation would look like d by 7.5 equivalent to t minus 12 by 60. As he is early by 12 minutes, he will take less time to reach, isn't it? Hence, we have used minus 12 here, and to convert minutes to hours, we have to divide 12 by 60. Solving these two equations now, we will get 3d minus 2d divided by 15, which is equivalent to 32 by 60. On simplifying further, we get the answer d is equivalent to 8 miles. Don't you think this process was a little bit tedious to solve? Yes, there are equations, that's how we solve math, but it is a little bit tedious. Don't worry, there is a shortcut to solve this problem. But you have to wait for the next video. We will discuss it in our next video, how to solve this using the strategy. Until then, stay tuned. It's Junaid signing off.